Today's lesson is stoichiometry, which is a method of predicting the amounts of products or reactants that are in a reaction. It is important, though, that you know that before you start doing any problem in stoichiometry, you first need to determine what the reaction is, and second, you need to balance it. So let's do that with my first problem, number 1. How many grams of HCl can be produced? This tells me that HCl is going to be my product. If 7.25 grams of Cl2 is reacted with an excess of H2. So my reactants are Cl2 and H2. Now we need to balance this reaction, but since this is a pretty simple one, I'm just going to go ahead and do it for you. Here we go. Now, in order to figure out the exact answer to this problem, we're going to use this balance equation as well as a series of conversions. We have 7.25 grams of Cl2. And set up my conversion. And at the end of the day, I'm going to want grams of HCl. So, the first thing we're going to have to do is cancel out grams of Cl2. How we're going to do that is with a conversion that introduces 1 mole of Cl2 weighs what I'm going to call 71 grams. Now, my grams have been canceled, and I have moles of Cl2, which is not my target unit. I'm going to cancel out moles of Cl2, and how I do that is I'm actually going to have to use the ratio of Cl2 to HCl, because that's the chemical we're trying to get to. That ratio is 1 mole of Cl2 for every 2 moles of HCl. Now, my moles of Cl has canceled, but I have moles of HCl, which is actually not what I want. I want grams. This is going to lead us into our final conversion. We're going to need 1 mole HCl, and then its molar mass, which, for rounding purposes, I'm going to call 36.5. Now, when I do this on my calculator, I'm going to type in 7.2 times 2 times 36.5. Then I'm going to hit enter. That number that appears when you press enter, divide it by 71, press enter again. Then you should get an answer of 7.5 grams. What this means is if I had 7.25 grams of chlorine gas and I had an unlimited amount of hydrogen gas, I could use that to create 7.5 grams of hydrogen chloride. Let's do another problem. This other problem, we're going to talk about how many grams of, in this case, iron can be produced if 10 grams of aluminum is reacted with an excess of iron 3 oxide. Again, step number 1 is figure out what the reaction is and then balance it. So iron is being produced. So iron is definitely going to be on this side of my reaction. And aluminum is reacted with iron 3 oxide. Now, this equation is actually not finished. This is a single replacement reaction, And they have not mentioned the other substance, but we all know that there must be aluminum oxide on the other side in order to balance. Aluminum has a charge of +3, oxygen has a charge of -2, so my result will be Al2O3. Now I need to balance, which again, thankfully for this problem, is rather simple. And now, once I have a balanced formula, I can begin to actually start thinking about this problem. So I have 10 grams of aluminum. And at the end of the day, this problem is asking me for grams of iron. So let's start our conversions. We know that grams of aluminum has to go on the bottom, and we're trying to get to another element, so my middleman unit is always moles. For this, I'm going to be rounding a little bit and say 27 grams is 1 mole of aluminum. Now, I know I have to cancel moles of aluminum, and I need to get to iron, so here is where I'm actually going to use my ratio. And the ratio is, for every 2 moles of aluminum, there are 2 moles of iron. Now, you can write 2/2 here, and you can also write 1:1. For every 2, there are 2. For every 1, there are 1. Then, finally, we just need how much does that mole of iron weigh. It's going to be 56 grams. When you go to your calculator, you do 10 times 56, press enter. That results 560 divided by 27, and you are going to get 20.7 grams of iron. One last problem. How many grams of, in this case, we're going to say sodium sulfate. Let's introduce some polyatomic ions, make this one interesting. If I start with 200 grams of, in this case, sodium hydroxide. With an excess of hydrogen sulfate. Now, with this problem, again, step 1 is always write out the formula, write out the reaction, and balance it. Sodium sulfate is being produced, so it will be on this side of my reaction. And the reactants are sodium hydroxide and hydrogen sulfate. Now, there is nothing else that the problem states, but we know that we have to make sure that this problem is balanced. And you're going to see that there's an OH on this side, and there's an H here. This is actually a double replacement. And what you will get is HOH or H2O, water. Now let's balance this. There you go. Balanced. Now, I'm going to let you try to solve this problem here. If you have solved this problem correctly, you should have somewhere around 355 grams of sodium sulfate. You might have rounded slightly differently, but it should be very close to 355. I look forward to seeing you in the next video. Happy 2020.